right. Get this all going. Presentation.
Ooh. Sorry.
Full screen. Nice. All right, does everyone have this up on their screen if they want it up on their screen? All right, good. Is it legible from the back even with this font size?
Yeah.
Yeah, good. Cool. All right. So yeah, I'm going to talk about React Native. So it was released about 2 months ago. If you look at my GitHub profile, I have a public commit streak of about 60 days, and there's no coincidence there. So I've been doing it nonstop pretty much since. Oh, I'm supposed to be louder. I'm getting some indication. Microphone might be useful, but yeah, I've been. If you look at my no, never mind, it's gone. So okay, React Native. What is it? So React Native is a way for you to write mobile applications using React.js in a very similar way to how you would write web applications using React. So essentially, if you can write apps for the web with React, you can write them for iOS and soon also for Android. I don't know about any other plans for other platforms at the moment, but those two main ones will be possible within 4 months. One key differentiator here is that React Native doesn't use web views. So who's familiar with Cordova or PhoneGap kind of thing? Can you put your hand up if you've heard of it and have some idea? Probably, yeah, like most people. So the way Cordova works, for people who aren't familiar, is everything is just inside of a browser window inside of your app. And so it's all HTML and CSS and JavaScript. And they give you this way to communicate with the native side, but your whole UI is done through the same thing that you would do for the web. And we'll go over why that's not necessarily such a great idea all the time. So I think anytime you talk about React, you at least have to explain what is React? Why does it exist? You know, there's a lot of people who get really annoyed with all the new frameworks coming out all the time. Very recently at Van.js, there was a talk by Godfrey Chan about Ember and about hype fatigue. Right? So hype fatigue meaning a new framework comes out, you latch onto it, you're really excited, and then you run into some problem, and then you repeat that cycle over and over with the new frameworks. So yeah, why React, right? I mean, it's just another thing to learn. So I think there's some very good reasons to use React, but maybe I'm a bit biased, but I'll explain them to you, and you can tell me if you think I'm biased or not. So let's take a step back and think about server-side views. So when you want to render something, and by render I mean render the markup. You're not actually putting pixels into a buffer, right? We're just saying you want to render the markup for a page. What you'll be doing on the server side is, let's say you're using Rails. In your controller, you'll find some record or records from the database. You'll put them inside of an instance variable, and then you'll render some view where you substitute some text in that view with some dynamic content that you get from the data that you've pulled out, right? And I don't think anyone who's done it enough really has a hard time with that, right? It's a very simple model. You get the data, and then you just render the whole view from the data, right? All the markup. It's pretty simple. So that's fine, but you do run into a lot of limitations with it, especially now where pretty much all websites are expected to have a much higher degree of responsiveness than what you'd expect from the typical request-response cycle over HTTP, right? You can't just, every time you want to change some data on your site, force a page refresh for the client. That's a pretty bad user experience. And so you have to think, okay, how am I going to update these on the client side so that I can have a more responsive and better user experience? So you get into a few situations. So you can, okay, first option, rather than do what we were doing before where we just fetch the entire page, we can get some partial from the server and then just replace that partial. So this approach is used with PJAX and TurboLinks, or just with Rails where you submit a form and you get back some part of the page that maybe perhaps even has some JavaScript embedded in it to execute some certain thing. But usually what it's doing is it'll just be replace some element with this content. And so you're just replacing entire subtrees of the DOM with some new string of HTML. So that's one option, which is, right, that's fine in some cases. Second option is something like client-side templating. So if you look at something like Backbone, you'll have something, like underscore ships with the templating library. That's just a simple example of it, where you'll have something similar to sort of ERB. And essentially, you do what you're doing in option one, but you do it on the client side. But the key thing is you're still replacing some entire subtree of your DOM with essentially a string of HTML. And there are some negative consequences that come with that, so we'll look at that. But again, that's valid in some use cases. And the third one, which maybe not everyone can read down there, is direct DOM manipulation. So you could imperatively add, remove, and modify DOM elements. So an example might be, let's say you click the check mark on a to-do, you might find that one and add class completed to it. When you add a new to-do, you might select your list using, let's say, jQuery, and then append a list item with whatever the name is inside of it. And it's just like string concatenation and building up an HTML string. So those are three options. Maybe there are others that you guys can think of. That's pretty much all I could think of. There's like slight variations on them, but I think that's what it kind of comes down to. So these are a few of the problems that you have. So when you replace subtrees of the DOM, it discards some state. So state might be like the focus state of a text input. So if you're typing something there and you want to validate on the server and then like replace something to show an error message and then you replace the whole form, then you're typing and then suddenly your text field is unfocused and maybe you've even lost the value and all sorts of things like that. So you quickly find out, okay, I can't just like replace interactive portions of my page entirely. And then you also run into issues with like scroll position. So maybe you replace something entirely and then your page jumps and then you've lost wherever you were scrolled to on the page. And it's also just slow and so imperative code, on the other hand, is pretty hard to write. It's error prone and it sucks to maintain. It's the classic like jQuery spaghetti situation, right? Nobody likes that. But most things are pretty imperative in the browser these days. So just to discuss imperative UI a bit more, because it's a pretty important point. Let's say that you have a notification bell that has these three states. So you have a notification bell where you have no notifications. You have one where you have between 1 and 98 notifications. And then you have another one that has 99 plus, and because of that, it's on fire, right? So these are the states that it has, but how many state transitions do you have to take into account for this? Can anyone guess what it might be? I took these slides from someone else, these three specific ones, who is from Vancouver, so you might have seen it before. 9, yeah, right? So this is O(n) squared, and so you would end up with, you have to transition from nothing to nothing, nothing to n, and yeah, all these kind of transitions. So I'm sure you know about that kind of thing. So some kind of code that might implement this, it might look something like this. So you have, if you see on the right the number of conditional branches that we have, there are a total of 7 conditional branches. So the first one, if the count is greater than 99 and you don't have fire, then add fire. And obviously this is still like pseudocode, and there would be more complexity to add fire that is still hidden here. Otherwise, if it does have fire, remove the fire. If the count is 0 and has, right, all this kind of thing, you have to take into account all these different details about the states and then how you can update it from that state to get to the other states that it can possibly get to. And as you add more states, it becomes quite a bit more complex pretty quickly. So what if we could have the ease of rendering the entire page each time, but the benefits of the direct DOM manipulation, right? So I think everyone agrees that rendering on the server, as I was saying before, is pretty straightforward. direct DOM manipulation seems to be the best approach for performance and for not messing up some state on your page. So this seems kind of ideal, I think. So what we would like is some kind of functional UI, rather than saying, here's how you transition between these states, and then checking what state you're in step by step. Here what you do is you just define the condition for each state. So there's 3 states, there are 3 branches. If the count is 0, you just render the bell. If it's less than or equal to 99, you render the bell with the badge showing that number. If it's not matching either of those conditions, then you render the bell on fire and have a badge that indicates 99 plus, right? So this seems like pretty nice if we could get this. And you can, because this is actually valid React code, so that's good. And we'll look at how that's possible. Because you're probably thinking something along these lines, like, yeah, but isn't it really slow to just re-render the entire page? Probably everyone who's used React before is just like, shut up, I know what you're talking about. But this is for the rest of people, so just like have a beer or something. Yeah, so that's probably what you're asking, something along these lines, if you're even following at all what I'm saying. So isn't it really slow to re-render the entire page? I mean, yeah, it would be, right? If every time you wipe out the entire page and then recreate the entire DOM, it would be incredibly slow. And thankfully, we don't have to do that. So let's look at what the solution is to this. So the ideal, we want to re-render the entire app every time the data changes. The problem is that DOM is stateful, it's complex, and expensive to manipulate. And that's why it's slow, because it's very complex and it's expensive to modify it. So if you look down there, you might not be able to read it unless you have the slides open. So if we call object.keys, which is just a way to find all of the attributes that exist on an object, on a simple div with nothing else related to it, we get an array with 122 items. So that's a lot of different properties, and these all have certain behaviors. And when you render a div, you have a buffer backing it for rendering. So all these sorts of things, and it becomes pretty intensive. Whereas if we compare that to a React div, there are 6 keys on it. So you can imagine the comparing how lightweight this React div is to an actual div. It seems like one of them is a lot easier to manipulate and to store in memory. So then our solution is to use these React virtual DOM divs and other elements to create a lightweight tree that mirrors the actual DOM. And so every time that you change the data in your application, you re-render the entire tree using the virtual DOM, and then you do a diff of the new virtual DOM with the old virtual DOM, and then React will generate a set of imperative instructions that will update your UI so that it goes from the old state to the new state.
Yep.
I think that's pretty cool. Actually, I'll be honest, the first time I heard about this, I just thought, it's not going to work. Like it's going to not do something sometimes, and then you're just going to, the flip the table over thing. That's what the first thing that came to mind for me with this. And I was like, oh, I'll just stick with Angular.
Why?
Yeah. So, yeah.
So that only works if you don't call does it fully render an app or just render the container that it cares? Like if I signal and change the data that has a as a state inside say a menu clause, then would it actually trigger the render on the other side as well?
No, well, it's a bit more intelligent about how it does that. I'm saying as like a blanket statement that it will just re-render the whole app, but yeah, it's more clever than that. There are some optimizations for only doing things that might be affected. So it would, in that situation, just re-render that subtree that has been dirtied. So it looks something like this. You have the JavaScript interpreter on one side, and you have the browser native engine on the other side. The browser DOM will send over input, status, events, anything that happens on the page that the virtual DOM might care about. virtual DOM will then process all that, re-render where applicable, generate this set of instructions, and then execute those on the browser DOM. So let's see an example of that. Looks good. I might have to go over this one. Okay, so if I click here, it increments the number of clicks. So this is the code here that runs it. I can't change it. I'm not that cool, I guess. But you can click here and it'll update the number of clicks. But if you look at the code, at no point do I say inner text or text content or anything like that, right? All I do is say, here's what this looks like. When this is rendered, there's a div with an h2 inside of it, and then this span, when it's clicked, we'll call this increment count function, and the span looks like this. It says the count, and it says clicks. And then all we have to do at that point is manage the data. So React shifts the focus away from manipulating the DOM and manipulating these objects on your page to instead focusing on the data that underlies it, and then trusting React to take care of updating your view accordingly. So go over to the next one.
Excuse me?
Yep.
What does 15 clicks mean at the top? I missed that.
Oh, it's just the number of times I clicked on the thing.
Oh.
It's not important.
Okay, sorry.
It's okay. So I went ahead and opened up Chrome debugger, and I'm not sure if you're familiar with this feature, but if you open the inspector and then go to the Elements tab, you can right-click on any element and then say break on, and then whatever the condition is. So you could say break on subtree modification or removal or that kind of thing. So I just said break on subtree modification for the parent for this component. And so then I clicked, and then it brought me here. So as you can see what's happening, you see the whole stack there. It doesn't matter so much. What's more important is up at the top, it's just calling set text content. So set text content, the text value is 1, and the node is the span that we're interested in changing. Right? So it's just gone ahead. This is the only operation that happens when we update it. And this updates the UI for us. Right? It doesn't change the header at all. It doesn't change the div at all. It's just able to tell from diffing these two, okay, the only thing that changed is the text was 0, now it's 1. So to update the browser DOM state, we just set the text of that span to have 1. So, all right. So you might have noticed something that really annoys people. I'm going to go back a couple of slides so you can see it again. Right? This looks an awful lot like HTML, right?
Yeah.
Can everyone see that? Is everyone annoyed, like angry right now? Yeah, you're pretty unhappy, probably. I mean, I didn't like it when I first saw it, to be honest, again. So an interesting thing about that is, I mean, it's not necessary, but people do get pretty annoyed. Like, this is on Twitter. These are just I just searched for JSX terrible to see what people thought, and that was like a common point where people complained about React. They would say, "Oh, like fine, do your framework, but JSX, why do you have to extend React? This is or JavaScript. This is terrible. HTML separation of concerns and blah 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 blah." Everyone like just not happy. And like even now, this one, the first one there is on May 11th. This web developers, stop it with this JSX stuff. It's terrible. Thank you. So clearly that guy thinks it's amateur hour, right? He's not happy. All right, this is probably hard to read. I'm going to increase the size of it a little bit. So this is what actually happens. So JSX is a compilation step. So you take this render function where it says return div, then you have some content in it with, you've injected some JavaScript inside of these curly braces, and then close the div. What that does is convert it to return react.create element div, null, don't worry about that, hello, etc. Right? So it just converts it to JavaScript function calls. But it'd be really annoying if you were nesting this. Like we can edit this one here and put like a, I don't know, like each one, and maybe inside of here put like a span, 5 views, I don't know. Oh yeah, my keyboard doesn't work. by the way, if you don't have AppleCare and you use your computer for like 8 hours a day, not that I do,
Yeah.
you probably want to get AppleCare because your keyboard is going to break. So, and it costs like $400 something to
Or is
replace.
it upgrade yearly?
Upgrade yearly. Well, I'm sorry I'm not swimming in cash like you do. Just like smash my computer each year and buy a new one. All right. So yeah, that's how that works. It just converts it from this HTML-like syntax into function calls. Let's go over here again. Okay. So then just a last point I wanted to make about React is the difference between composite and native DOM components. So any of these components we define here, like comment list, comment form, comment box, these are all composite components, whereas the things like div, h1, etc., that actually have representation in the DOM, those are the native components. And so when you look at the DOM, something like comment list, it has no representation in the DOM. You won't see like a div that represents that. You might, if any of you have used Backbone, usually when you create a view, you'll say like this view's root element or whatever it's called is like of this type of element. Like you don't have that. Those things are purely in the virtual DOM, and only the native DOM components will actually show up there. So it doesn't create this extra stuff for you that will pollute your DOM. That becomes important later on, though. Just for now. Okay, so summary. React app is a tree of components. I don't think I mentioned that yet, but it is. So summary. Each component has a render function that returns a subtree of virtual DOM nodes. Every time the data changes, you regenerate it. You know, simple way to say it. There are obviously optimizations. Regenerate it, diff it, do the updates. That's essentially all there is to that. Okay, so that was the introduction. Now I'll talk about mobile. I'm not even joking. I hope you plan to stay for a while. So here are some of the tools right now that are available. I focus more on iOS here because there could have been a billion things. But here are like some of them that are available right now. So you could use something like web views /hybrid with when I say JavaScript bridge, that's the way you communicate with JavaScript to the native side. So all of these, as far as I know, are, I don't think triggers. I think triggers slightly different, are based off of Cordova, which actually was created, I think, in Vancouver and originally called PhoneGap. So you might be familiar with it by that name. So that's the one where everything is inside of a web view. Everything on the page is inside of a web view. It's HTML, CSS. You can literally use the same code in there as you would on the browser. So that has its advantages. You have native, so just like write in Swift or Objective-C, or if you're doing Android, Java, or maybe they support Scala now or whatever. I think Go maybe. Then you have compile to native binaries. So probably the most popular one that I know of, I don't know much about this area, is Xamarin. So that's C#, and it compiles to, it basically has its own runtime that works on all platforms, and you compile down to this native binary and ship it off. FireMonkey is with C++, I think. Ruby Motion, which is the box there, is Ruby. So if I had to pick one, I'd probably pick Ruby Motion, but thankfully I don't have to pick one. So then the other option is native components with a JavaScript bridge. And so this one's a bit more of a complicated JavaScript bridge, and basically it's used for generating your, handling pretty much all of the logic in your app. And the JavaScript code will control the native components. So it's the same as if you had created those native components in Swift or Objective-C, except you actually manipulate them through JavaScript. It might seem kind of unclear for now. That's totally okay. But yeah, so these are the sort of options. Titanium, and the other one there is native script. So I'm going to tell you why I think some of these aren't necessarily, basically what are the deficiencies that I see in them. So if we look at Xamarin, you essentially suffer from the same problem that you have with native, which is that you have different APIs on each platform. So what I've heard from Xamarin developers is that even if you're a Xamarin developer, you'll be like a Xamarin iOS developer or Xamarin Android developer. So it's not like you still don't escape that platform tie, but you do get to share some code between the platforms. But the UI is completely different. So an example of that is, if you look at this next one. So this is an iOS thing to add an item. You can see it's using a UI view controller, and you're using Core Graphics, Foundation, UI Kit, all that kind of thing. So you do have to know the frameworks still. You're just writing it in C#. And then this is like a Windows Phone version. So obviously it's written entirely in XML. Anyways. So another downside is, I mean, look at the price of Xamarin. Like, that's a pretty huge barrier to entry. If you just wanted to be like, hey, I'm going to make a Xamarin app this weekend. Like, yeah. But, yeah.
I like the closed source.
Sorry?
GCC is free and it supports iOS.
Yeah, I mean, yeah. Tell me what happened. I have no idea. I just based it off of this. I haven't actually used Xamarin. So, and were you referring to like FireMonkey as that option, or for Xamarin specifically?
You compile it.
Oh, okay. Yeah, I mean, I guess you could come up with something, but yeah, sure. It's definitely perhaps a viable option if you come up with your own thing, but that's a lot of work. So yeah, it's closed source. They're pretty proud of it with their badge, closed source.
How weird.
Yeah.
That's actually fair. I thought you put that there kind of as a joke.
Yeah, there you go. You got it. You got
It's
it.
actually there.
No, I definitely put it there. So another problem that you have with a lot of these things like native and compile to native is you have a really slow development cycle, right? And there's this XKCD comic that comes up probably every time anyone mentions compiling. So I guess I had to mention it. Right? Xcode. I think at Facebook they said something like they average 50 crashes a day per engineer using Xcode. Don't quote me on it, but that's what I've heard. So. And then there's all these other issues with it, like it'll just start indexing and you'll have to wait forever for that to happen, or who knows what other problems you could have. You have a slow deployment cycle. So if you look at the App Store, it takes 8 days on average to get your app approved, which is actually an improvement over before. So that's pretty slow if you want to do something like A/B testing and you want to release different versions of the app and then get some feedback on what features are working. Like, it's going to take forever. There's some workarounds for that kind of thing, but yeah, it's not ideal. You're stuck with some pretty unintuitive layout systems. I mean, maybe auto layout becomes something that you can work with after a while, but like again, it goes back to that first point of learning different APIs. You have to learn the different tools for every platform too. So sure, like iOS might do auto layout, that might be fine. Then you go to Android. Android does who knows what they do. You get XML or whatever with Windows Phone. Like, it'd be nice if you could just do one thing. But anyways, not a big fan of the interface for this either. I think most developers just like to like sit in their Vim or Emacs or whatever and do stuff. Not really dig through an interface and like fiddle around as this slow thing then crashes as you drag something. It just doesn't seem fun. Oh, that skipped a few. Let me just go back here. Spoiled that one. That was fun. Let's just keep going. Don't worry. There's plenty of slides. Okay, so if you use web views, then you have to re-implement all this complex native UI, which like a team of engineers at the top companies in the world spent maybe a year implementing. So good luck, right? I mean, maybe you can copy that, but okay, first of all, you get this entire thing. I mean, here I'm comparing two versions of Android in the same app. So let's say that a new version comes out and completely changes this one. How long is it going to take for one of these hybrid WebView frameworks to catch up to that? Well, I mean, if you look at like Angular or Material, it still sucks, and it's however many months after Material Design has come out. Try using it on your phone. Oh my, it's terrible. It's so slow. So anyways, I mean, it works great on iOS, but who wants to use Material Design on iOS? Anyways, yeah, so you have to re-implement all this. And this is just like the first part of it. I mean, this doesn't even include animations. If any of you have used the newest version of Android, it's all based around animations. So sure, you can look at this static thing like this. Like, sure, oh yeah, I could re-implement that in HTML and CSS in like a weekend. Okay, fine, maybe, probably. But yeah, good luck getting those animations, and especially performant on multiple devices with different WebView versions. No, it's not possible right now, is my opinion anyways. So then you get things like this. Like, this is an Android phone, if you guys aren't familiar, and people just like shove some iOS UI in it. Like, oh, you know, whatever, right? Or then you use this Angular material thing, which, like, what's that? I don't even know. I just opened it up on my phone. Like, it was like chunking around there really slowly. And this isn't using like some bad built-in WebView. This is using Chrome, the latest Chrome that I downloaded on Android L on a Nexus 5. And it sucks. It's really slow. You should try it. So then you can look at, yeah, like I was saying, the animations. So I don't think I've ever seen anything like this implemented well on the web. I don't know, maybe someone has. I think it's stopped for some reason. It's supposed to be more, whatever. Usually what you'll see instead is, rather than something like this, where there's this nice transition open, it looks like a smooth continuation of the UI, you end up with something just like that, where it just sort of pops up. And that's how you know you're using something that isn't a native app, right? You know right away, like, no, something just like popped up. Yeah. And all sorts of things like that. I mean, the APIs for animations just aren't that good on the web right now.
Can you show the don't for hierarchical timing?
Sorry?
Can you show the don't for hierarchical timing?
Sure. I think it just all shows up at the same time.
Uh,
Yeah. I mean, you can do that kind of thing with like GreenSock API or whatever, but yeah, it's a pain. And you don't need to re-implement it if you're using native, so you have some nice APIs. So another issue is you get poor performance and non-native feel. So this is my best attempt to make something like performant with a web view. It came out okay, and actually it looks better in this video than it actually does on the phone. It feels like it's pretty responsive, but you can feel there's like a little bit of lag as that pops up, because it's just, web views are bad at animating opacity, even though you're recommended to use opacity as one of the things that it's supposed to be good at optimizing. But I mean, I had to like dig into the internals of Ionic and rip a few things out and change things, submit a pull request like, it was not a nice experience to get that working. And then you'll notice also it has just kind of like an ambiguous UI, like, is it Android? Is it iOS? So you kind of just have to create your own UI framework so that you don't get spotted as like an imitation whatever, and then people will just get, they won't like it. I apologize if anyone uses, I mean, there are definitely use cases for this kind of thing. Just saying, for like more intense apps where you want to have a real nice feel to it, and native with like very smooth animations and native components, it's tough. So here I just looked for lag, which is one of the many keywords you could use to find slow performance. I just went on the Ionic forum and looked for it. It's a very consistent problem that comes up. You run into issues with limited access to native APIs. So if you use an app and you click like Facebook login, and then it doesn't just jump over to your app and log you in, but it instead opens like a browser inside of the app and then asks you to log in again. You're like, but I'm already logged into the app. Why doesn't it work like the other ones? It's because it's probably done inside of a web view, and frameworks like Ionic actually make it. I'm sorry, I'm not picking on Ionic here. It's just the one I'm most familiar with, so that's why I keep mentioning them. So what they end up doing is if you have to modify the underlying files, you would have to change this both on Android and iOS, and you would basically have to break out of their standard build process, which you lose a bunch of the advantages of using the tool in the first place. And so what people end up doing is just using like a built-in a browser inside of it that doesn't track any of your sessions, so you have to retype your login information inside of one of these things that ask you to get Facebook for your phone. So it's pretty awkward, I think. So ultimately what it comes down to, though, is this idea of the uncanny valley. You can totally get away with doing hybrid WebView apps if you don't try to actually be like the real thing. If you just do your own thing, right? Then it's like Wall-E, right? You're kind of cute. But if you look like the person over there, right? It's like, it's pretty close to being human, but like, it's definitely not human. And it just doesn't feel good, right? You look at it, you're like, I don't like that. I don't like what's going on there. So it triggers something psychologically. I don't know what it is, but that phenomenon is known as the uncanny valley, and that's pretty much my main complaint at the moment against web views. But all of these tools suffer from having an API for mutating the UI in an imperative way. So you don't get the functional UI that we looked at with React. Okay, I'm sorry for being so negative there. It's just, yeah. Okay, so let's talk about React Native then. So here are some of the features that stand in contrast to what I was just discussing. So compared to paying Xamarin, if you're going to actually have a commercial app and you're paying $99 a month for every platform and every developer that you have, so however many thousands that would be per year, this is free and it's open source. One of those other tools, you run into a problem with Xamarin runtime, like, well, I hope they fix it soon because you can't do anything in the meantime. Right? So that's nice. You can, like, it's very open to pull requests. You can go in and look at the code. It's very approachable code. I would highly recommend reading through it for React Native. There's live reload, so you can get instant feedback. So it's like what you would see in a browser. When you turn on live reload, you change a file, you see it automatically update in the window. The exact same thing, you get that here. And I want to emphasize again that it's not like reloading a web view inside of it. It is actually, these are native components that are being manipulated. You get, the functional UI, which I would say is a better abstraction, and I would like to hear any arguments for why that is not the case. I'm interested. You get Apple-sanctioned OTA updates, so OTA is like over-the-air updates, so you don't have to go through the Apple submission process so long as you don't change the main functionality of the app. Yep?
How does it work? Like, who hosts the actual source?
Well, you could do something like when you open the app for the first time, it would download the JavaScript from wherever you're storing it, and then at some interval or over WebSockets, it could just check, is there an update? If there is, download the new one, store that, use that as the code base. We could talk about that more afterwards. There's an example later that sort of shows integrating that kind of thing.
So it basically means that it provides the library to do it, but you still have to manually implement it into the app.
Yeah, I would say it's like maybe 10 lines of code, so it's not too bad. You get the Flexbox layout system and CSS styles. To an extent, they've implemented a useful subset of CSS styles. Flexbox is great. If you haven't used Flexbox yet, it solves so many problems that you have with layout. I personally, I don't want to make websites without Flexbox anymore, although I have to, but I don't want to. Although it is pretty well supported these days, I have to say. So you get to use the same skill set and similar APIs on each platform. So regardless of whether, at the moment, this is like it's not necessarily something that you can put to practice because the Android version of React Native hasn't been released yet. They are using it internally at Facebook and building it and building apps in it, but they don't release code that they're not using in production, and they haven't actually shipped an Android app with React Native, whereas they've shipped several iOS Android apps. Or sorry, iOS React Native apps. That would be cool. But yeah, the idea is you would still write. There would be platform-specific APIs because certain idioms related to the user interface don't exist in iOS or don't exist in Android. Like you get that little button in the corner for Android that, I don't know what that's, action button or something that you see with material design. That just doesn't exist in iOS, so there would be an API difference for that. But you would add it to the page in the same way. It would just be a React component that you would drop in. And so you would be able to learn how to use it within a few minutes, certainly. Yeah, so that's a big perk. You can share common code with JavaScript. So now the other tools, you can do that to an extent as well. However, in this case, you can share it with an additional platform too. I mean, with WebViews, you can share it, yeah, with web, but with like Xamarin, you can share it between all your mobile apps. But with React Native, you can share with web and all your mobile platforms. And I think that was probably a significant driver behind it as well, because you get libraries like Relay and GraphQL, all that kind of thing that are coming along. Yeah?
Just to clarify, like React Native is running on the server side?
No. React Native runs on it runs in JavaScript core in a separate thread on iOS. Yeah, so you have the main thread that runs the your regular iOS code, right? And then you have a separate thread with JavaScript core where all of your JavaScript app logic executes.
So it's like it has to be distributed by Apple on the devices side.
Well, I'll show you another way that you can do that afterwards. You would embed it, like you would distribute the app in the same way. If you wanted to ship some iOS app, you could ship it in the same way you would any other iOS app, but you just get the added advantage of you can update it at any time over the air by just swapping out the JavaScript that powers it.
Okay, let's say I built an iOS app and then submit it to Apple for approval, and then like they say, well, by the way, you need React Native, and not all the devices have it.
Oh yeah, no, that ships with it. Yeah, it's all the React Native Objective-C libraries will be compiled into your binary, and then
so they're included.
Yeah, and then you'll ship the JavaScript component as just like a bundle inside of your assets. So it's nothing different from what you normally do. Yeah, native UI components is a big one, and what I think is really nice is the powerful plugin API. So it's so easy to make your JavaScript interact with any of the native side. So like wrapping different components that aren't built in, or accessing some functionality like, for example, the Facebook login. We'll look at that more. So live reload. So if you have the app open in the simulator, you can press, I think it's Command Z or something like that, which will open up this developer menu. And from there, you can choose to debug in Chrome. And so your JavaScript, rather than executing inside of JavaScript core, will actually execute inside of Chrome. You can enable live reload, so it'll pull for updates and reload the UI every time there's an update. Unfortunately, it's not hot reload yet, so it will refresh the entire app. So if you were in a different tab on the page or something, then you'll lose that state. But I think it is possible. It's just not done yet. So yeah, the functional UI. I won't go over this much again, but I think that's a huge advantage to it. And yeah, so the way it works is it's pretty similar to what we saw with the React in the Web diagram. So in the virtual DOM, we have like a React.view rather than React.dom.div. And then in the iOS runtime, that React.view is mirrored by a UI view. So those arrows say the exact same thing. And it's actually the same React JavaScript for the most part running inside of JavaScript core. There are just a few plugins to make it behave slightly differently to know that it's running inside of an iOS environment and properly update things accordingly. That's a bit offset. But okay, let's look at an example of this. So this is a simulator running a React Native app. What we saw before, right? I'm just clicking, it's updating number of clicks, and this is essentially the same code. The only difference is I changed from a div to view. rather than H2, I have text with some certain style. Rather than span, I have text. So you can think of view and text as analogs to like divs and spans. So yeah, it's the same thing, right? I mean, the only difference here is the what's being used in terms of the native elements. So let's click through. All right, so what's actually generated? We saw before it generated a set text content, right? So what's actually happening here is this is all this stuff that happened to actually create this. So from React, when it first initializes, it's creating a view. It's giving it tags so it knows how to refer to it, setting these attributes on it, creates this other view with our initial text. And then later on, what we do is when we click on it, this is the first operation that's sent over. So to the UI manager, we just say update view. We give the ID of the view, what class it represents, and then we tell it what changed about it. So the text changed to 1. And so that's all that's sent over from the JavaScript side to the Objective-C side. And then that's handled basically by this UI manager class that is part of React and does what you expect it to do. So it's very similar, right? I mean, it's just the API for changing the native component is different than set text. Instead, it's update view and passing this text in as an object. So yeah, the over-the-air updates, this is actually directly from the terms of use for I don't know, the Apple Store. So as you can see, they recently added in there. Before it was, so an application may not download or install executable code. Interpreted code may only be used in an application if all scripts, code, and interpreters are packaged in the application, not downloaded. The only exception to this foregoing, or to the foregoing, is scripts and code downloaded and run by Apple's built-in WebKit framework or JavaScript core. So Apple does support this. This is a thing that they say that you can do. So it's not like they're going to refuse your app because you've gone ahead and made it so that you can update it live. So yeah, going over Flexbox a little bit. Does anyone have a good solution for vertically centering a div in CSS? I have a decent one. Yeah. What's your approach? Famous. Yeah, that might work. I've used it a little bit. Yeah. So, but then you're working inside of is that Canvas that you're in? Oh, okay. So.
Is there a VO line?
Oh. Yeah, I mean, you could, like that would be one of the many attributes you would think would work, and then you would try, and then you'd find out that it doesn't.
12 years ago or something, I wrote a page where I could line vertically.
Yeah, it's
HTML4.
there was some situation in which whatever you did there, and probably a common situation where it wouldn't have worked. You probably just didn't run into that case. So there are a lot of cases where that kind of thing breaks. The best solution I found, if you're wondering, is basically to absolute position it and then do a transform, translate y and translate x that offsets it by negative 50%. It works, but actually you don't have to do any silly hacks like that if you're using Flexbox. So here's a vertically centered div. Essentially, all you have to do here is on the parent say justify content center, and it just works like it should. It should. There are all sorts of other examples. This holy grid layout with sidebars. That's another common problem. What if you want to have multiple columns and then you want all the columns to expand to take up the same height? There's all these different things for that are a mess. It's just so easy. It's such a great model, and I highly recommend checking this out. And also, I think it's flexboxin5minutes.com is another good one. And you'll find if you just play with React Native, you'll pick it up pretty quickly. So one thing that you'll have noticed from this is that, yeah, in the previous example, I had some inline styles, right? I said style equal something. So if you've been around long enough, I think the guy that just spoke up over there was mentioning HTML4. Back in the day, yeah, you'd be like, inline styles? Hell yeah, what else am I going to do? Right? But these days, people will shun you and fire you and stuff if you do that, probably. So this is funny. Christopher Cadeau, who is one of the creators of React Native, did a talk about inline styles with React, and he used this exact photo from The Simpsons as an example of the reaction on Twitter after his presentation. People were not very happy with it, but it's an interesting approach because so you can right. Those are it has his presentation and his slides there, but I've just picked out this one slide from his deck where he talks about the issues that this solves. Right, so you have all these global variables. I mean, if you look at like Bootstrap, because another one of his slides that introduces like 600 globals, right? You run into a lot of problems. I mean, CSS has got variables recently. Like recently, variables. You can now use variables. And anyways, isolation, right? Who's been bit by that? Where you have some component, and then inside of that you have some style that's affected, and then you have to like do important and stuff like that, and you just like feel, I don't know, dirty. Right? Sharing constants, so you might have like a color that's used throughout the app, so maybe you use Sass and you make like a variables file, and then you require that, and then you put that in there. But yeah, these are all things that that are actually solved by using inline styles in CSS. And so I highly recommend checking out his talk. Obviously, he has a whole talk about this, so nothing I can say in several minutes will do any justice to it, but that's my attempt. Okay, so the native UI components that come with it, you get view, text, image, scroll view, date picker, picker, list view, navigator, switch. You can read it. Let's look at, so this is the UI Explorer app. So if you clone the React Native repo and go into the examples directory in UI Explorer, you will see this app that you can run that basically just demos all the components. So we can look at like the date picker here. So you can like scroll through and check out these various things in the date picker. List view. You know, I mean, list view is probably one of the weaker points right now. It's decently performant up to a point, but once you get a lot of items in the list view, it's unfortunately not as performant as it could be. But that's a work in progress. You can get list views with like this paging where you get sticky headers on it. If I can actually scroll, right? It's fancy, right? So that's all built in. You get a map view, navigator for routing and doing certain kinds of useful actions. I mean, there's all sorts of things. You should definitely check it out. And then there are a bunch of community built components. I made a video component that uses the AV player library. It's not very difficult to do. There's a camera component that allows you to access the camera and use it however you like, and all sorts of things, audio recorder, etc.
Is it just a matter of time before those things become part of React or not?
It's possible. So they're trying to keep the standard library
Pretty bare.
pretty small and just focused on the essential things, because then it's less surface area to update each time, and then the community can sort of take it down or take ownership. Clicking on the wrong window. Okay, so here's an example of how you would write a bridge module that would allow you to use native Facebook login. So this would use the Facebook app for your authentication. You jump over to it. You could say, yes, allow this app to use it, and then it would jump back. So none of the in-app browser thing or anything like that. And like I literally wrote this within 2 hours of React Native coming out, having never written Objective-C before. It's not hard to learn. It's not that tough, right? I mean, yeah, and it's powerful. I mean, if we look at now this next slide where I'm actually using it in JavaScript, if it updates on here, yeah. All you have to do now is say Facebook login manager.new session, and that'll call the new session function that I just created on the native side. And when that's complete, it'll either pass me an error object with a description, or it'll give me the info object that has like the token and whatever, all that other information. So that was one kind of plugin. That's the bridge module. So that would be if you don't have like a view representation of it, if it's not something that you would embed inside of your component hierarchy. So like not a div or a header, you know, that kind of thing. Another one is view managers. So let's say you want to have that native iOS slider. So that's UI slider in UIKit. So what you would do is just create this manager class that implements a view function that returns a UI view, and you essentially just create that UI, right? You alloc init it, and then register to receive notifications of whenever certain things happen, and then you can propagate these events down across this JavaScript bridge to your React side and pass along any data you need. Here we specify what attributes you can set on it. So minimum value and maximum value actually map directly to the UI slider properties. So we don't have to change the name of that, but there is a way to change it. So that's a simple one there. I just intentionally put in a very simple example. I'm sure if you read this, it took like 2 minutes to read it, you probably understand. So here's the JavaScript side. So right down here is where I'm saying RCT slider equals required native component RCT slider iOS. So that's a bit of a weird API, but what it's doing essentially is it's saying create a React component called RCT slider that is based off of the Objective-C class RCT slider. Now I'm saying Objective-C, but you can actually use Swift as well with React Native. So based off of that, and the wrapper class for this component, so we can add some more functionality on top, is going to be called slider iOS. And so this is where I define slider iOS. So I say, here are the properties for it. This is how it looks like when you render it, and I just render RCT slider inside of there. And there are various reasons why you could do that. You can read the documentation for it. But in this example, a slider, like the built-in component, you can't actually change the height of it. That won't do anything. And so it just gives a fixed height, applies that style, and lets you go on and do what you want. So yeah, that's that. And then when we want to actually use that in the code, it's just like this slider iOS. We pass in minimum value, maximum value, and then what to do when it's changed. And obviously, you don't have to implement slider iOS. That's already implemented and shipped with React Native. But if you wanted to, you could. All right, so that's it for this one. I'm going to talk about how am I doing? Yeah, 8 o'clock. Yeah, that's fine. Talk about internals a bit. I'm hesitant to go into too much detail, but I'll talk about it at a high level. So if you look at Cordova and how they implement a JavaScript bridge, what you have essentially is on the native side, you'll have a web view, and that will display your index that will include your app and Cordova.js. Cordova will create a hidden iframe inside of your app, inside of your page. And then what it will do is every time you want to execute a native functionality, so you have to do Cordova.exec, that will put whatever command you want to execute inside of the command queue as some array that would be like call this service with this this action using these arguments, and then call this callback function. Then it will serialize that into JSON, and it will store a reference to that callback, and just basically keep it there in the command queue. And as soon as it does that as well, it will trigger a navigation to the hidden iframe to a special schema, which is phone gap, semicolon, // And whenever that's done, the UI WebView delegate will essentially watch for changes in navigation. And so when you change to that schema, it will execute some JavaScript inside of your WebView to flush the queue and bring this JSON object over to the iOS side. And then it will basically parse that out and execute the commands that you had in the queue. And then if there are any callbacks, it'll call those callbacks. So you can see this is actually code from the Cordova thing here. Fetch commands from JS. Pretty straightforward. You get the web view, string by evaluating JavaScript from string, and you just call Cordova.require Cordova/exec.native fetch messages. And that just gets it flushes the queue and gives you this serialized JSON that you can execute. So React Native's JavaScript bridge is, it's fairly similar in that concept of you have, rather than a command queue, it's called message queue. So you can look at messagequeue.js inside of React Native to get some more understanding of it. It uses the iOS run loop rather than having like a poke, so it doesn't say, oh, hey, I've updated this view, change some iframe thing, and then send this over. You actually have this run loop happening. So at 60 FPS, which is 16.67 milliseconds, it will flush whatever needs to be performed on both sides. So you could have actions that are queued going from native to JavaScript, and you could have actions that are queued from JavaScript to native, and it basically take care of all that. And yeah, it handles the conversion of JavaScript data types automatically. It also will convert a lot of other data types like UI color or like CG point rect and whatever, things like that. And a key point here as well is it's completely asynchronous. So JavaScript is an interpreted garbage collected language. And so if you were running that on the main thread and then you executed something and then it started doing garbage collection and then you tried to scroll, you'd be like, oh man, I can't, what happened? It just froze, right? But that doesn't matter as much because it won't be happening on the main thread. So you can still respond to input, and that will just be batched and sent over. Yeah, so I put a couple of exercises here if you're interested in learning more. They're pretty straightforward. You just get React Native running, open the UI Explorer, and open up the UI Manager and add a breakpoint to somewhere inside of Update View. Update View is a very important function. There's Create View, Update View, Manage Children are some really important functions for how this works. So you can just add breakpoints in those and inspect the stack, see what's being called, it'll give you a lot of insight into how it works. Another exercise is open up message queue.js, as I mentioned before. Set debug spy mode, which is just the variable at the top of the file. Change it from false to true, and then just look in your console inside of Xcode, and you'll see this huge stream of messages as you do things in your UI. And so that's where I got the, in a few slides ago, where I showed the example of how we updated the text inside of that clicking app with React Native. I just took those directly from there and put them here. So another concept that's pretty important. So so far we have this main thread, we have JavaScript core thread or threads, and we have a shadow thread. So what's done here is pretty similar to what's done in Async DisplayKit. Has anyone used Async DisplayKit before? Familiar with it? Has anyone used the Paper app, Facebook Paper? Yeah, is that even available in Canada? I don't know. I've tried to use it. I can't. But yeah, so essentially how it works is UIKit was developed at a time when iPhone was single core, and so UIKit is not thread safe. So if you create a UI view on any thread that isn't the main thread, and you don't do anything with it, you'll probably crash your app. And so what Async DisplayKit does is so UI view adds functionality on top of CA layer, and then you have these nodes in Async DisplayKit, which are essentially they're like wrappers around UIKit views, and they allow you to perform layout in a separate thread. And so you're able to, and various other optimizations. And so you're able to have a lot more happening inside of your app. You're able to work with these extreme animations. I recommend looking at an example from, just go on YouTube and look for Facebook Paper. It's the kind of thing where, I mean, they worked on the tool for building this for a year, and then they built the app for a year. And these were some really smart guys. One of the guys that worked at Apple on these frameworks, and so they've really made something interesting there. And so a lot of the ideas are very similar with what's done with this shadow thread in React Native. So when we pass in attributes from React like flex or padding and margin, like those have to be somehow converted into layout. And so layout is essentially, when you talk about layout, you mean how do you compute the top, left, width, and height of some box in your view. So this is done using a library called CSS layout. So Christopher Cadeau, who I mentioned before, re-implemented Flexbox in JavaScript. He did some TDD in the browser where essentially he would write up a test case, test it against the actual implementation of Flexbox. How would it render? Would his algorithm get the correct layout for it? Okay, yes, tried a new test case, etc. I think it took him only 2 weeks and was able to re-implement it. And then it's actually quite funny. It's compiled from compiled from JavaScript to C and from JavaScript to Java using regular expressions. So check out the repo, it's pretty interesting. So there are some big advantages to this, though, because essentially you get to push off some pretty expensive operations that you might do normally on the main thread to a separate thread. And they're actually, at the moment, working on an animation API that will use this similar approach to really improve animations with React Native. And so one other point I just wanted to make here quickly was how expensive it can be for text as well. Because if you're working with text, you have each character has its own specific length, right? You have some font size, you have like kerning and leading, or however you say that, and you have right letter spacing, width, whatever, all sorts of different things about it. You have line height, and then for various languages, it can be more complicated as well. If you're using like Thai or Korean or Chinese, or if you're writing from right to left, there's a lot of stuff that needs to go on to determine whether you can fit some string of text inside of a container and how many lines that takes up, and whether you should truncate it and things like that. So by doing this in a separate thread, you take a lot of the load off and prevent some issues like causing jank in your application. I'm almost done, don't worry. So I talked a bit about the composite component before. So the same thing obviously is true in React Native, except instead of a native DOM component, right, where we have divs, we have native iOS components or Android. And so it's interesting. You can open up the React Native directory and search for update view and see where that comes up. So you can see this like React Native base component. So that's what's used when you to require native component. And remember when I did that, it required native component RCT slider. Basically, it just added this functionality so that when this updates, it actually sends the updates over to the native side. So it's not just some component that is living in the virtual DOM, but the updates will actually affect some actually rendered, and not just like markup renders, an actual element in the view hierarchy. I thought this was interesting too. So this is just another look at how composite components are working. So if we look at this one, we have a view, and then we have some components inside of it. All these do is like text with 5. And I pulled this bit out. This is what happens when you render your application. So it renders a root view, just like this, and then it renders your component, whatever the component is. In this case, it would be test composite components is like the main one for the app. Passes in whatever initial props, and you can forget about the rest of that stuff. So if we look at the view hierarchy, it's actually really interesting with Xcode. You can look at this very easily. You can just pause execution and manipulate it like you would in the browser. So we can see that this is the view at this top level, and then this RCT view is corresponding to this one. And then notice how here it's just text. So there's no like view wrapping this. You just get the text that comes out from it. So it's actually just what's the native components that are rendered. All right, so I'm getting pretty close to the end now. So I just wanted to show you some of the cool things that you can do because of a lot of the properties of React Native. So this is a tool I've been working on with a couple of other people. Chuck over there has been helping out with it in the back. So it's essentially it's a way for you to edit, play with React Native inside of your browser and then share the examples. My main motivation is I want to make it easier for people to submit bugs and have reproducible examples that you can then test on multiple versions to see if it's a regression and that kind of thing. But it's also just cool as like a JS fiddle or CodePen kind of thing. And so you can actually use that right now if you want at rnplay.org. There's also an app that goes with it. We haven't submitted it to the App Store at this point, so you'd have to actually clone it and build it yourself and run it on your iPhone. If anyone wants to play with it, I have my iPhone here. You can play with it after. So you just get a list of the apps that are available. You can go in any of them, like play with it, and then just swipe up with 2 fingers and exit the app and choose another one. And so this is an example of loading JavaScript over the web. So if we go down to this next slide, here's how you do it. There's an example, right? This is just directly from the code for that app. Really, it's just like these lines. Actually, so like 3. or no, not even that, but 2. It's pretty easy. It's just, yeah. I mean, there'd be a bit more if you actually wanted to download the app, but that's nothing specific to anything with React Native. It's the same way you do it in Objective-C. Like if you want to download something and store it in your file system, it's not a concern with this. There's also this really cool, that text looks weird, really cool app that you can actually use on your phone right now that will allow you to play around with React Native and see it on the phone without having Xcode installed, without having a Mac or anything. You can just go to exp.host on your iOS 8 or higher device and press download. It'll be like, hey, are you sure you want to download this? It might be unsafe. Just press download, right? It's fine. Trust me. And then you run it, and it'll give you some instructions for how to do it. Essentially, you just run it. It'll tell you install this npm package, and you do that, and then it's pretty straightforward from there. So if you don't have any of that set up, then I'd recommend trying it out like this. That's exp.host, or just go to rnplay.org. But it's more fun to see it on your device, I think. So. I also have a lot of stuff that you can look at for follow-up, but you probably just want to look at the slides for this. Tons of good information available everywhere. Definitely watch the presentations on it. There's some videos on Egghead that walk you through creating an app. The docs are good, whether React Native or regular React. You can come join us on IRC or check out my blog or whatever. I could just read the whole slide, but I'm not going to. All right. Any questions? Yeah.
So let's say a company develops a mobile site
Mm-hmm.
with React. How hard would it be to then say we want to make an iOS using React Native?
It's hard to say without looking at the app itself. If you're using Flux, probably you have a lot of the application logic decoupled from your components. So you would be able to use quite a bit of it. The components themselves, like if you had any composite component that was made up of just other composite components, you definitely reuse those as long as you re-implemented the composite components that it's made up of using the actual native views. Or, I mean, if you're not using inline styles, that adds to it as well. You're probably not using inline styles. Most people aren't.
I don't have anything in particular.
Oh, okay, just in general. Yeah, it's definitely possible. There have been people. Well, one person comes to mind who was just posted recently on the issues just to show off, like, hey, check out what I did, and he had this app running in the web browser and on React Native that was the exact same thing. So you can definitely do it. It's just what are the approaches? It's still really new, so there's not like a really straightforward way of doing it right now. But you can share a lot of code for sure. Okay.
I'm just curious. The virtual DOM that was a representation
Mm-hmm.
of the actual DOM, would it be a more like would it take up more memory than say if you just have a DOM?
I mean, yes, because
So you basically
more stuff is more than less stuff.
you
But
basically trade-
but at the same time, you would be doing other things otherwise. And so essentially the only approach to not using more memory or whatever would be to just have a static site. So it's like, what are you doing for it? It's a pretty good approach that
so
works very
in a
well.
sense, you're kind of trading memory for speed.
I mean, you could say that, but if you measure the footprint of it, it's really not a big deal. And so virtual DOM is being adopted by a lot of frameworks today. Ember is just about to launch Ember 2.0, which includes something called Glimmer, Glimmer, or something like that. It's basically a virtual DOM engine for that. You have Angular 2.0 they're discussing as well, including some form of virtual DOM for part of the rendering. It's basically like, this is an approach now that is pretty well accepted. I mean, in terms of performance implications, it's hard to say, like in terms of memory use. But if you look at the size of what these actual nodes represent, it's not very significant when you have just various keys on it that are essentially just storing a few properties on each one. Yeah?
You just commented on that, and a quick question is, apparently space for React is incredibly small because it doesn't have to maintain all possible combinations of changes. Anyways,
Yeah.
curious, do you have any kind of insights or anything to with, like architecture, like Flux architecture, anything like that, you would recommend us to look at? Obviously, you can't do a talk on it, but like for native stuff specifically that works with React Native.
So I think at the moment, I mean, I use my own Flux thing. It seems like that's a rite of passage for people who use React. You write your own Flux library. So I use that, but what I've seen recently, I like alt, and people are using alt with React Native, and it works just fine. It's a really nice way to get rid of a lot of boilerplate, so I would check that one out.
Have there been any security issues that have been discovered because React is so new that it tends to kind of security loopholes are kind of found on processing?
Not that I'm aware of.
Cool.
Question more about Android coming along with the UI components being have been responsible in some ways. Have they talked about maybe there will be UI components not only available on iOS, but only available in Android, where it's how you have this sort of do your magical thing and select which one to inject, and even not just that, but sometimes when you have tablet, when you want styling, how you connect, because tablet you have media query, CSS, but now if you're going native, then that sort of opens now you become developing this sort of abstract component, and then you need sort of multiple ways of injecting.
Okay, so I think there are a couple questions there. There's the first one about having platform-specific components. So that's already done for slider iOS, for example. So the suffix for a component that is platform-specific will be iOS. Where possible, they are trying to, for common things, use the same component on different platforms with the same API. So if you can have text that has the same API and works the same on both platforms, then that will be done. If you can have views in that way, anything that can be shared would be shared. If the API is too different, then that's something that you would need to split up into a separate component. So yeah, there are definitely different implementations depending on what it is and different platform-specific components. But again, a key thing there is that all you would need to learn is what are the attributes for this, right? You would need to learn, okay, this has minimum value, maximum value, or whatever on change. But so that's all you would be learning with the API. You wouldn't have to learn some entirely different markup language or layout system like you would with something like Xamarin using various devices where you're actually working with the low-level components. And so the second one.
For example, if you have a button in iOS that goes on the top where the material design have the Android button on the bottom, right?
Yeah.
Then in that case, when you put that button there, it's not only just the markup that is there, it's also has the styling that you can change, right?
So you'd probably make a separate component for that. And there's a main idea behind how they're doing this, and the philosophy is learn once, write everywhere, rather than the idea of write once, run everywhere, right? So rather than just writing it for one platform and having switches of if iOS do this, if Android do this, the idea is you know how to use it, so it's really not that big of a deal re-implementing this thing on another thing. I mean, if you really want to get the good experience and the unique experience for the platform, you have to re-implement some things, right? And so
it would be nice if they could actually come up with something an example where people would follow around and people have questions about how to do things the way, how to do things the way, once that pattern falls.
I imagine that will emerge when the Android version comes out. There'll be some patterns around that. But I believe the second question was about how you can handle the difference between an iPhone and an iPad and that kind of thing. So there are libraries that you can look at right now that will allow you to detect the different versions. You could render a different component entirely depending on whether it's an iPad, or you can adjust the styles. It's up to you how you want to handle that. And still, it's quite early, so there aren't really any best practices for it. So if you do play with that and find something out, that'd be cool if you put a blog post about it.
You said that React Native is free and open source, yet you did mention that Facebook is doing some significant stuff with React Native. So, who is are they the main driver behind React Native?
Yep, they are. And so now a key thing there was also that they only release work as open source once they're using it in production and once they're very confident in the quality of it. And so that's why, although the Android version will be open source, they do have it right now, and they are building, I mean, they're still building it up, and they haven't released an app yet for it. And so once they are confident that it is of high quality and it's something they're proud of, and that they have an app on it running in the App Store, then they will ship that as open source.
But once a developer builds an application, like they're submitting this to Apple, and at some point Apple may complain or kind of stop people from using React Native because like there's a significant interest of like a big third-party company like Facebook. What are the chances?
I don't personally think that's an issue. Politically, it seems like it would be maybe a bad idea for Apple to do that. And you have Facebook investing a lot in the platform. For Apple to do something like just shut that down entirely would hurt their App Store, right? People would be probably concerned about submitting any app to the App Store and building on that towards that platform if they just randomly decided that some totally reasonable technology wasn't allowed to run on it.
I think to add on that though, I think the risk isn't just unique here. The risk for that is across the board. So whatever framework you choose to use, there's the same risk there.
Yeah, totally. Yeah.
Unless it's Apple's directly, because that's in their best interest.
Right. Yep.
Do you know the OTA thing, OTA updates you mentioned, when you download JavaScript and change your logic, that's been well tested in the field. It seems like a loophole that people will use and that will back down.
No, it's definitely not a loophole, right? As I included in that slide, it says. Okay, so there's an example of how this is done with Ionic, an app on the App Store that does. So they have for the Ionic framework, which is one of those hybrid WebView ones that I mentioned. You can download an app called Ionic View, which allows you to download your apps, JavaScript, and whatever the assets for it, and then load them and execute them on your device. So this kind of thing has been done, and people will do partial updates of their apps. Right, you can have some of your apps still. I mean, JavaScript core exists, and you can have some basic bridge and that kind of thing. And so you could do that today with any app. It's again, it comes out like, would they change that or would they get annoyed with that? I mean, if your app is abusing that a lot, then maybe. But I don't see that as something that would, even if they did change that unilaterally, is like we cannot do this anymore. It wouldn't hurt you that much by investing in the platform, right? I mean, you would lose that feature, but presumably no one else would have that feature either. So then you're still on even ground with everyone.
Okay, awesome.
Yeah. Yeah.
It seems like this project has a lot of similar goals to Unity.
Okay.
Do you think you can have the performance to make games and perhaps even compete with Unity down the road?
So I'm not too familiar with Unity. That's a game engine, if I'm not mistaken.
Yeah, it's multi-platform, so it'll compile to native each of those platforms.
Yeah.
It can be for apps too. They're going toward that.
Oh, really? Okay. Yeah, I'm not too familiar with it, but I would probably put Unity in the same category as compile to native, rather than having being this sort of bridge JavaScript idea. So all the downsides that go with that. I mean, is there like a license fee for Unity? Is it open source? Yeah, so it seems like it belongs in that category of things. So, I mean, it could be compelling. I don't know enough about it to say, but yeah, it could be good. Does anyone want to see like an example? Do we have time? I could show you like an example of a couple of apps really quickly, or like are in place. Okay. All right. So I don't know if this is actually even going. Let's,